Hello, everyone. We're just allowing our registrants to register and also sign in into our session. So we'll just start in 2 minutes. Thank you very much for your patience. Yeah. Hello, everyone, and welcome to today's webinar, An Automotive Digital Transformation Journey with our partners from IoTco. My name is Virginia De Leon, and I will be your moderator today. I am the Digital Marketing Specialist at R3D International, and I am very excited to be hosting today's session. I am pleased to introduce to you today's speakers. Jean-Yves Durocher, Executive Vice President at R3D International. Mo Abu Ali, CEO of IoTco, and Isaac Bennett, Director of IT at Detroit Manufacturing Systems. Before I hand over the mic to our speakers, I have a few housekeeping items to cover about this presentation. First, today's webinar will be recorded and will be available to view after the live session. So watch out for our website and our social media channels for the posting. And next, we would love to hear from you in today's webinar. So if you have any questions for our speakers, please feel free to send them through the chat tab. And in addition, we will have a Q&A session at the end of the webinar. Now, I would like to kick things off by welcoming Jean-Yves Durocher, Executive Vice President at R3D International. Over to you, Jean-Yves.
Yeah, good morning, everyone, and thank you for attending our webinar. And we hope you'll enjoy the content and it will be practical for you and your organization. So we'll be talking today mainly on IoTco with Mo. But just before we jump in, I just want to take 1 minute to tell you a bit more about R3D. You could just move to the next page. Well, basically, we have been in business for 23 years. The manufacturing IT division of R3D has been in operation for a bit more than 10 years. And we have offices in Mexico, USA, Canada, and France. So historically, we have started early on with more on the ERP. We're an SAP partner. Over time, we got more involved into MES, MOM, and more on the 4.0 pillars, which today we spend a lot of time with clients, assisting them with those pillars. And with this, 2 years ago, we looked for a partner to focus on a deeper offering on the IoT and predictive analytics. And after some search, we became partner with IoTco. And Mo will tell you obviously about all the product and what it can do for you. But the main reason why we put this partnership in place is that the maturity of the solution it is getting into pretty much a mainstream, and it's off the shelf. This is basically what our clients are asking for, the tangible benefits, return on investment, and anybody getting into 4.0, any of the pillars. Obviously, you don't want this to end up as an R&D mission. So I think what you're going to see today is very mature, off the shelf. And without further detail, I'll pass the microphone to Mo, who is going to talk to you about the offering. So this is a short list of our clients. Very briefly, as you can see, we do have a good footprint in automotive and the industrial world. These are clients of R3D that we do work in a very proactive way. So Mo, you could go on with the next page and get into the topic.
Yeah, Jean-Yves, thank you very much, and good morning. And I thank you all for being on the call. It's been great getting the partnership on the road with R3D, and also working with companies like DMS and Isaac Bennett on their digital transformation journey. Very briefly, who is IoTco? IoTco is the Internet of Things company. And I'm one of the managing partners here. I bring about 20 years of experience working in automotive at companies like Toyota, and then working in the manufacturing execution system and analytics space. So we as a company, our DNA is the automotive industry. However, the solutions we bring and the services we bring can apply to a variety of industries. We bring two domains of experience around digital transformation. Our key domain is around the smart factory applications within the four walls of the factory, and assisting the factory to strategize and deploy solutions and technologies to improve the factory operations. But also on the smart product side, where we can perform analytics for remote monitoring and diagnostics and other applications to add value to the end user. So within the smart factory and smart product applications, we go to market with three practices. Our core practice initially is around digital transformation consulting. We also have Industry 4.0 training, where we collaborate with industry, collaborate with partners like R3D, and also collaborate with universities to provide education on Industry 4.0 and related topics. On the technology side of the business, we have a very strong understanding of IoT, manufacturing execution systems, and predictive analytics products. And we work with our clients to help them shape their digital transformation journey, and to help them also execute that journey in a phase approach. So this is who we are as a company, to keep it very brief. And many of our clients, actually, especially ones who are part of the National Association of Manufacturers, NAM, there's an annual gala, an annual leadership award, and last year was the first ever AI leadership award for artificial intelligence. And this is where MAXION wheels, for example, received an award. They were the only automotive client to receive an award. And when Isaac introduces himself in a few minutes, he actually was part of MAXION wheels at the time, and he was championing our digital transformation efforts at MAXION wheels before he joined DMS. So it's a great recognition here by NAM of some of the work that we do. So why are we here today? I would like to first set the stage around what is IIoT, what is predictive analytics, and what are some of the key technologies, especially around predictive analytics, that are paving the path to help manufacturers in their digital journey. And then Isaac Bennett, I'm pleased to have him here with us today, and he will take the time and talk about their specific digital transformation journey at DMS and their lessons learned. And then we'll wrap it up with some questions. Again, if anyone has any questions at all during the call, please just drop it in the chat window, and we will get it answered in the last 10 minutes of the call today. So let's get started. The field of Internet of Things, or IoT, is by no means a new field, right? Maybe a new naming, but this field has been around, encompassing many industries and many things and devices for decades. Jet engines operated by GE and Rolls-Royce have been collecting data, sending data, and analyzing data for many, many years. Power plant operations have been analyzing data for many years. So if you think about it, safety critical industries like aviation and energy and renewables have been using analytics and have been using data collection and IoT and the internet for many years. But in recent years, this evolution and know-how and best practices have started to venture into the industry or into the factory space. So when we talk about the Industrial Internet of Things or IIoT, we're talking about how to apply the internet, the connectivity, and the analytics within the manufacturing operation and the supply chain. So we're looking at the machine layer, the CNCs, the PLCs, the sensors. We're looking at SCADA, supervisory control data acquisition systems that are aggregating that data. We're looking at an MES layer, manufacturing execution systems that some companies have to tie the plant floor layer to the business layer, your enterprise resource planning layer. Some refer to this as your ISA 95 layer of operations. And this is actually a standard. It's a 4 or 5 level standard within manufacturing today from the IT perspective. So when comes initiatives like Industry 4.0 or the Fourth Industrial Revolution, this was initially a German, European-born initiative that has spread its influence around the world, right? And it's all about applying information technology and converging it with operational technology to build a bridge between these 4 layers that you see here, which actually in many environments are still fragmented, or some of them may not exist, like MES or IoT, right? In the US, the National Association of Manufacturing actually referred to Industry 4.0 as Manufacturing 4.0. And many companies, corporate entities have their own namings, including, Brilliant Factory at General Electric, for example, is a corporate naming within their company. So when we as a company talk about what is a digital and analytics strategy for a manufacturer to go and help them reach Industry 4.0, we're talking about 4 pillars, okay? And in many cases, we start from the right and we go backwards. We talk about what is the ROI? What is the business case? Is it uptime related, quality related? What do you want to achieve? So thinking things from the end, and then going backwards to talk about, are we connected? Are we collecting data? Do we have the right analytics team and strategy in place and tools to do performance analytics and predictive analytics? And then what is the right technology to be selected and tested and piloted and scaled into the operation? Okay. So keeping this in mind, again, thinking things from the end, the business case, right? So when we think smart factory, connected factory, we're thinking, what are the use cases within that factory that can deliver results to the bottom line of the organization, directly impacting their P&L, their profit and loss statement. So OEE, overall equipment effectiveness, is a key metric today used to track and monitor operations globally, right? So you have your uptime metric, your availability of your assets. You have reduction in unplanned downtimes, right? How can I mitigate this by using predictive maintenance and collecting data in real time? We're talking spare part systems and spare part inventory that needs to be optimized. If we're able to predict failures early before they occur, we're able to reduce spare part inventory and have just-in-time replenishment of spare parts in the manufacturing plant. If we're able to have a proactive approach to doing maintenance, a predictive and preventive approach versus a reactive approach, we're able to improve maintenance scheduling within the operation. So when we look at our client base today, we're seeing a minimum of a 5 to 20% overall equipment effectiveness efficiency gain by getting connected, by having real-time data, and by using tools like artificial intelligence and predictive maintenance within their manufacturing facility. And we're seeing them achieve those values within a less than a 6 to 12 month period by having the right approach and right strategy. We're seeing 5 to 10% uptime improvements. we're seeing them tie into their maintenance systems like SAP PM and feeding predictive insights to SAP PM or other solutions. And by doing this, they're able to reduce spare part inventory by anywhere from 10 to 25% on average. We're seeing manufacturers use analytics to reduce labor time to perform the maintenance, because now I know what to fix and when to fix it, so I can optimize my maintenance schedule. Many of our clients have achieved 5 to 25% reduction in labor time and even eliminated overhead maintenance. They completely are staying away from overtime or weekend maintenance, for example, on a Saturday, Sunday, and by being able to optimize and have a predictive maintenance schedule in place. So business case drives technology selection and drives the behavior and strategy of digital transformation. One of the first return on investment calculations we've ever done was with an automotive OEM with a lot of industrial robotics, where we deployed an AI predictive maintenance solution. And in that plant, the average cost of 1 minute of downtime was almost $10,000. So it is significant. You're not making cars. If the line is down, you're not making cars. So if we are using AI and we're looking at how many failures actually happen in a year, I mean, let's face the facts. Robotics don't fail all the time. They're very rigid equipment. But when 30 of them on average fail every year, with 30 minutes of estimated unplanned downtime, leading to such a single robot failure value that you see here, using predictive maintenance and having or even under promising the prediction accuracy down to just 50%, so only catching 15 of the 30 robot failures, this automotive OEM was able to achieve such a strong result from applying AI and predictive maintenance in their factory. Now, we're not saying, or I'm not saying that your 1 minute of downtime is $10,000, but think of what is your 1 minute of downtime cost you, and how many asset failures that are unplanned you usually have per year. And simple math here based on uptime and based on prediction accuracies, which by the way can reach 80 to 90% in a real world setting, can give you a very quick ROI calculation by just looking at uptime improvements and moving towards a predictive maintenance approach. So when we look at two case studies briefly, we always think, what is the value? What is the velocity of doing the work? What is the scalability of the work? And what's the ROI? These are the four key metrics that we look at to assess our digital transformation success. And when we look at a company like MAXION Wheels, a predictive maintenance solution was deployed there in less than 3 months on 7 of their most critical asset types. That proved value within 6 months to the manufacturing company and was scaled as a template, or is being scaled as a template to over 10 manufacturing facilities in their steel division. When we're looking at Bocar with high pressure die casting equipment, we're looking at high scrap rates, okay? And artificial intelligence can be used not only to predict maintenance issues, but also to predict scrap and quality issues in the manufacturing floor. The casted parts are running with a cycle time of almost 10 seconds. So the AI solution has to make very rapid decisions in less than the cycle time of the part, within almost 6-7 seconds, to automatically scrap a part or accept a part based on big data collected from the casting cell, almost 50 parameters, right? So here, we're not just telling them if the machine is going to go down, but we're actually prescribing to the machine to make a decision to accept or reject a part. A 1% scrap reduction in a casting plant equates to almost a $250K per plant per year in annual savings. So hard dollars can be achieved here by using AI analytics and connectivity in what I would call a scrap-rich environment, like in the casting process, for example. So the National Association of Manufacturing actually awarded both organizations the AI Leadership Award last year and this year. So ROI dictates technology and dictates the use case. So what is the technology behind all this? Okay, we see a 3-layered approach. We always refer to the data lake. And if you don't have the data lake, it's important that we partner with you to create that for you. So we're collecting data from the asset, the process, the quality, the workers, and in a standardized fashion, this data can flow into an artificial intelligence-based solution engine that can deliver you the use cases to deliver you that business case. So predictive maintenance is focusing on the machine. Predictive quality is focusing on the part that is being produced by the machine. So we talk about predictive metrics. We talk about health of the machine and the components. We talk about prediction of when the machine might fail before it fails, remaining useful life. And on the scrap side, we're talking about, is this a healthy part? Green, yellow, red. Is it going to pass? Is it a warning, a suspect, or is it a predicted defect on the part? And then what is the reason for that defect? Is it a temperature parameter, a pressure parameter, that is leading to the failure on the part that I'm predicting? Okay. So zero downtime, zero scrap operation is the vision that we have, a worry-free process for manufacturers to use connectivity and analytics and drive shop floor improvement. And we do it in a very systematic way, okay? You do not need a data scientist or a PhD on staff to utilize these solutions. These solutions can be pre-built as much as possible with a workflow, an analytics workflow. A data model that is predefined, we know exactly what parameters need to be captured from the PLC and from sensors that you might need to add on the machine, especially if the machine is older. We know how to process that data, how to extract statistics and features from that data, and then how to train a machine learning algorithm that can learn the baseline and then trend the behavior, which is your health over time, and then start to offer predictions and diagnostics on what is the root cause of the failure and when the machine might fail before it actually fails, shifting away from a reactive approach and a time-based approach to maintenance to a more proactive and predictive approach. So now the question becomes, there's a lot of variety of machines on the factory floor of different types and different ages and different processes. So there comes the idea of solution templates. I have robotics on the factory floor with different axes, and each axis has a bearing, and the joints might fail as you're moving the robot over time, right? So predictive maintenance of each axis of the industrial robotic, whether it's a FANUC, a KUKA, a Denso robot, it doesn't matter, robot agnostic. I have machine tools, CNC machines. I have spindle bearings that might fail, or ball screw feed axis that might fail, or my coolant, my lubricant might degrade over time and cause an issue on my part. So a series of templates relating to CNC machines. I have injection molding equipment and high pressure, low pressure casting equipment, where not only maintenance is important, but also predicting quality and defect issues is important. I have stamping equipment, vibration-based analysis on specific areas of the carriage and the die may be crucial in a stamping area. We've also done projects where we use sound or acoustic to listen to the sound of the part being hit by the stamping press and inferring from the harmonics of the sound, which you obviously can't hear with the human ear, but you can hear with a sensor, and inferring that this might be a bad stamp or the machine might be having a problem. So a more non-intrusive way, instead of having to mount and drill a vibration sensor, you're listening to the sound data. Or I have ancillary equipment surrounding the factory, compressors, pumps, motors, gearboxes that might fail. So the idea here is a library of solution templates where the connectivity is well understood and proven, and the AI and the analytics recipe is well understood and proven, leading to rapid deployment in 8 to 12 weeks without the need of a data scientist or a PhD on staff that has to be able to configure these solutions, right? Our typical go lives are very rapid, allowing customers to start using predictive analytics in a very rapid fashion, and then proving results in weeks. So very quick example, robotics, right? It's robot agnostic. When we look at predictive maintenance, we're looking at capturing, belt issues, backlash issues, bearings, motor brakes, lubrication, maybe starvation issues on the machine. These solutions should be intuitive, right? a maintenance person should be able to look at a dashboard and quickly make a decision without the need of being a PhD on staff. So when a maintenance person looks at a screen like this, they can quickly understand my asset is healthy because it is closer to the baseline. My asset has started to degrade, and now I see a prediction window with an accuracy of when it might actually fail, and I have a 2 to 4 week window to actually react. And I can see that my fifth joint or axis is going to be the actual key failure area on my robotic. When we used to work at Toyota, we used to go and fix all the 6 joints on all the 6 axes of the robotic in a standard operating procedure every few weeks, right? But with these solutions now, I can actually save labor time and save spare parts by going in and fixing a specific area on the machine, which is diagnosed by an AI solution. When I look at a CNC machine tool, it is a more complex piece of equipment. You have a tool that moves, you have a feed axis, you got a spindle bearing, you got the coolant. So there are multiple templates and multiple areas of data collection that you would need here in order, again, to deliver an intuitive solution with an intuitive dashboard to the maintenance organization so they can quickly see, hey, I want to look at my spindle. My spindle bearing has started to degrade. This is the failure remaining useful life of my spindle bearing. And I can clearly see that my SKF bearing has an 8 kilohertz frequency of failure, or BPFO, that's the outer race of the bearing or the inner race of the bearing. So within a component like a bearing, we can even pinpoint very clearly which area of the bearing is going to fail before it actually fails. Very detailed or in-depth analytics can be achieved. So now that we're connected, now that we're collecting data, now that we're analyzing data, okay, at the end of the day, such solutions can run standalone, but in many cases, we close the loop and we tie those solutions with a maintenance system so that the maintenance organization can use this data and these solution templates and start driving information to SAP PM, for example, to do predictive maintenance within SAP PM. Most maintenance systems today are static and they're completely disconnected from the factory floor. So by having predictive insights and sending data to SAP, for example, we're able to support the maintenance team to optimize their PM schedule, assign labor to do the maintenance, and even order spare parts before they need the spare part. So we've actually partnered with R3D on a special adapter to bring predictive insights like machine health, remaining useful life, and even requests for spare parts into SAP PM. And this is a very key integration that we're bringing out to all manufacturers. So you can have proactive alerts and you can have what we call predictive replenishment of actual spare parts, helping you reduce your spare part on hand and helping you reduce your labor time by having a closely knit integration with your maintenance environment. So with this setting the stage of kind of what's happening today in the industry, around ROI, business case, connectivity, analytics, leveraging your existing systems like SAP PM, stage for my good friend Isaac to kind of tell you what is their journey and where are they today and where they want to be in the future. So I'm pleased to have Isaac Bennett here with us today. And Isaac, thank you for taking the time, and the floor is yours.
Thanks, Mo. Appreciate always listening to your presentations. I always learn something new when I listen to your presentations. I do hello from rainy Detroit. It is rainy and lightning and thunder. So if you hear some background noise, that's probably the thunder in the background, or it's my 3 kids downstairs. So it could be either or. I will tell you a little bit about Detroit Manufacturing Systems, but I also want to tell you my personal journey, because I think telling my personal journey of how I got to where I am with digital transformation is important. I think it is relatable, and I think some people could learn some things from my personal journey. So you'll hear me talk about Detroit Manufacturing Systems but you'll also hear me talk about, Mo mentioned my experience with MAXION wheels as well. So Detroit Manufacturing Systems hasn't been around too long. They've been around about 8 years. They are a facility that does value-added assembly, just in time, just in sequence. That's their main business. And if you look down in the pictures there, you'll see the kind of stuff that we are assembling. So you see a Ford cockpit there, and then you'll see on our Toledo facility, we're dealing with the Jeep products mainly. We also do injection molding. So we do have some machines where we are doing some injection molding for some of those vehicles that we're putting together. And we are a joint venture with Forcia. So our CEO is the majority owner, but we are a partner with Forcia. So we have a lot of resources behind us with a big company, Forcia, which is great also. So yeah, you can go to the next slide there, Mo. So yeah, I'm currently the head of IT at Detroit Manufacturing Systems. I have about 10 years experience in automotive. Before that, I did a lot of consulting with smaller businesses. And part of my experience is starting off in smart manufacturing, industry 4.0, whatever you want to call it. For maybe the past 5 years, I've been delving into that and running projects having to do with that. Go to the next slide. Yeah, so I just want to give you a picture of what my journey was, and it'll give you an idea of where I come from, and also might give you an idea of what path you want to take. So I think it's important that I describe where I came from and what I am doing currently and what I did in the past. And the journey really began with me managing plants and facilities in Europe, and then also I managed some plants and facilities in North America. And the message that I got while I was managing those facilities, and I managed the IT people, so let's get that straight. I was the IT manager or regional manager for Europe and for North America at one time. So I managed the IT people in those facilities, in the plants, and that was really my first experience with working directly on a manufacturing floor. I'm big on communication, so I would often talk to the plant managers and see where I could help them. And the message that I got on pretty often was, we need more help on the manufacturing floor by the IT department. And in that process of talking about that and bringing that message to our CIO at the time, we decided as an IT department to come up with a presentation of how IT can help the manufacturing facilities directly on the plant floor. And that turned into a presentation about Industry 4.0, smart manufacturing. And I'm going to talk not so much about the technology, but about how you can get a project launched, how you can culturally shift your organization to start thinking in this way. And the first thing that we found as I started doing these presentations across the world is that departments don't really talk to each other. They're very siloed. And you'll see the pictures of the silos down there. They're doing their own thing and they're doing pretty well, but they generally don't talk to each other. And I was often surprised that even on the manufacturing floor that the quality department had no idea what the maintenance department was doing, that type of stuff. To no fault of their own. That was their dominion. That was what they knew. But we quickly realized that even some plants have different maturity levels. So some plants, depending on where you are, have more automation than others. Some plants have MES systems, so the manufacturing execution systems sometimes didn't even exist. Departments don't collaborate, and data is not gathered, or sometimes it's gathered just for compliance and not used. And a lot of times there's no standard solution for collecting that data. So Mo, you can go to the next slide. So as we went down this transformation and IT started looking at this stuff, it's very, very easy to get overwhelmed with looking at the Industry 4.0 framework, the Industry 4.0 picture. There's a lot of different technologies that we started looking at, and we ourselves were a bit overwhelmed. How can we do Industry 4.0? Because it's such a huge concept, and from cloud computing to augmented reality to smart sensors, data analytics. In fact, I started back then. I think I was one of the first guys on the block to get an Amazon Alexa device, and I started buying smart devices for my house and seeing what I could do by talking to Alexa, and that for me was a microcosm of what you could do or possibly do in a manufacturing environment. But also we quickly realized that, okay, let's look at the core and really the core concepts of Industry 4.0, and Mo alluded to it, is data and analytics. And I would add one more to that, which is connectivity. But all of those devices and all of those things that you're doing in that framework of Industry 4.0 is going to generate data. And now you hear the thunder. Hold on. At least minimize the background sound effects. So yeah, data was very important. The second thing that I also realized was that the world today in general is a very, very fast-moving, agile world in general. So information passes very, very quickly. The world changes very, very quickly. And you can see even today, we are living in a disruptive environment. So in order for you to survive, to survive as a company, we needed to start thinking of, yes, Six Sigma is very important. We don't get rid of that. We don't get rid of lean concepts. But how can we make decisions rapidly and faster? And how can we adapt faster than our competitor? And that for us came down to the connectivity of that data. And the business is going to make business decisions, or they should be based on data, and that's the way they make the best decisions. So how can we do that as quick as possible? Well, you can go to the next slide. So really, we talk about those silos. We talked about data. So really, where do we start? That was the big question. Where do we start? So we wanted to create a compelling case for innovation, and a fully aligned case for innovation inside the company. So how can we collaborate? What can we do? Where do we start? Was the big question. Go to the next slide, Mo. So we started looking at the maturity level of our facilities and trying to figure out where are we on the map of Industry 4.0 or smart manufacturing. And this is kind of a busy slide, but you see a lot of the steps there on the right, 1, 2, 3, 4, 5. Really, most facilities, I would imagine, in the companies I've been in, have been more of a reactive automation. I would say Detroit Manufacturing Systems, as we discussed this in our Detroit Manufacturing Systems, we're kind of in between a 1 and a 2. But then we wanted to have a strategic vision, a strategic roadmap of where we want to be and what is the final result. And this is a very, of course, high level. But there's the idea of, yes, we're reactive. Then we get to the anticipating and site excellence. But then how do we replicate that across all of our plants? And then not only that, the next step is how do we replicate that throughout the value chain, not just on the factory floor, but across our chain of value? And then how do we connect in our partners? So there's even a step farther than just across the value chain, but how can we connect in our other partners into this ecosystem and start using data and automation throughout that entire life cycle? Go to the next slide. And Mo alluded to this. So the second issue that we discovered pretty rather quickly, and as we're doing this analysis of our plants and where our plants lie, is and this is also part of the silo conversation. Very much the IT domain and the operation technology, the OT domain, is separated. And in this day and age, those walls are crashing down. So we quickly realized that we need to really get as much collaboration between those devices on the plant floor and the people who are taking care of those devices and the IT domain. And specifically with Detroit Manufacturing Systems, they had an old MES that was mainly run by the IT department. And so we're looking at a more modern manufacturing execution system that will give us that connectivity and flexibility. But also, it's really important to me that we, as an IT organization, involved as many people from that plant floor who know those machines, who know the PLCs, who know the data that's coming out of those machines, that they are very, very connected to that manufacturing execution system. They understand that data better than anybody that's coming up that plant floor. And then they team up with IT to how to get that data out of the plant floor and then use it across the value chain of the business. Go to the next slide. So you see, breaking down silos, that IT/OT is a perfect example of breaking down those silos and getting that data. Data collection and connectivity and reporting is the foundation. That's by no means Industry 4.0. I think we've been doing this for years and years and years, so gathering data and connectivity and reporting and putting up andons and doing all that stuff. But if we don't have that across our plant, and especially in Detroit Manufacturing, they have a very, very robust system that has to have traceability. But then how do we use that? We don't want that system to be siloed. So how can we use that system across quality, maintenance, inventory, production? And then what can we do in injection molding? Yeah, we're doing assembly, but we started talking about what can we actually do in injection molding. And I put at the top there, and I talk about this a lot, that the concepts are all really big, and the idea of where to start is always a big question. But I put think big, start small, fail small, prove value, and scale fast. And so I'll give you an example of that. I think with us in Detroit Manufacturing Systems, there's a lot of ideas around being able to, even because a lot of our processes are controlled by people with the assembly process, how can we actually collect data from those stations, from those people working on those stations, and gain value from that data? You can go to the next slide. So this is more pictures of the MES system that we're putting in, a more modern MES system. It's based on a HTML5, so it's web-based. We can put it on any screen we want. It does all the integrations that we need to. We can integrate into the ERP, which is SAP. So we integrate into SAP. We are looking at integrating into our supply chain group. We're looking into integrating also into our quality. So there is a lot of different things that we can do with this new MES system. You can go to the next slide. So predictive analytics. So we're very much saying, okay, we have all this data. What do we do with the data? And I can give you a perfect example, and I think this fits along with what Mo was talking about when you're thinking of where to start. When I was with MAXION and we were looking at where to start, we wanted to, and I wanted to very much match. I have to justify spending money on a project like this. And so I very much wanted to match what we were doing with these new technologies with the business. So we walked into and don't think that you have to be a very super best technology ever in a plant to start doing Industry 4.0. And this is why I tell this story, because The facility we walked into was a very had some very old machines, like I would say close to 50 years old. They did their job. It was stamping machines, roll forming machines. They did their job, but when that machine broke down, it caused a big problem. You talk about downtime and how much money that could cost, and I don't remember how much money that cost when that machine went down, but it was a problem that it would go down. And so we went in there and talked to the people on the plant floor and got, the guys straight from the plant floor. Leadership is important, but the guys on the plant floor really know what's going on. And we got them and sat them down and said, where are your problems? And then we focused not only on one machine, but then we actually dove deeper and said, okay, what can we do on this machine? Now, they had other facilities that had similar machines. So we knew that if we could solve problems on this machine, thinking big, but starting small, that we could expand this to other machines. So we not only looked at this particular machine, but looked at what specific part on the machine was the problem. And there was a top tooling and lower tooling issues on this machine that would break and that would cause the downtime. So we focused specifically on that. And we put sensors. The machine had nothing as far as sensors, so we retrofitted that with sensors. And these days, with the cost of sensors is pretty low, and that's what's enabling us to do this in manufacturing. We were able to do that at a pretty low cost. And once we sensored those up and we connected them in, we actually sent that data to a server in the cloud, so everyone could see what data was flowing in there. And then we started having the data science guys sit down across the table from the manufacturing guys and look at the data. And the manufacturing guys could tell what was going on by looking at the data, and the data scientists could use their model and train the model and start testing and then improve the model to be able to tell if that machine was going to fail. And the great story about that is that they did predict, once they got the model running, they were able to predict the machine would fail in 10 days. And just as they predicted, the machine failed in 10 days. And the value from that, being able to predict, and specifically with the upper tooling and lower tooling of that specific machine, had a lot of value for them in that facility. You can go to the next slide. So finding a proof of value project, and this is kind of what I talked about with that project that we did in that facility with that very old machine. Again, think big, start small, prove the value, and scale fast. So you don't want this to turn into a data science project. You don't want it to drag on forever. And that's what I learned very quickly, is if we can find a specific problem, even a specific part of a machine that's a problem, that can be replicated across the company or to different plants or to different machines, that's where I want to start. I think in that case, if you can show that part is a problem and it can take down a line, I think it's very easy to show the ROI and the business case behind that. So we really got together and found a specific problem with a specific machine for those people on the plant floor who understand the problem, conducted those workshops, sat down with them and focused on a very specific issue. And then we ran out and started to work and see if we could prove value and review what we've done and then take it to the business. And I think it was pretty easy to sell once you can prove that return on investment. Next slide. Yeah, so that is my journey, and I will turn it back over to Mo. I think Mo wants to talk about one more slide here. So I appreciate the opportunity, Mo, and I'll hand it back over to you.
Thank you, Isaac. Thank you very much. And I fully agree to the think big, start small, and prove value approach. And that's actually the first bullet on our small summary and call to action slide here. If you have not started your digital journey today, or if you're looking to improve your digital journey, a think big, start small approach is the right way to go. And as Isaac alluded to several times, starting small is all about selecting the right plan, the right area in the plan, the right team behind it, and to make it operational now with a smaller scale proof of value. And a proof of value should have the technology component to it, like your MES or your predictive system, and then your ROI and the business case side to it that you must prove in a shorter period of time. Whether you're running factories or whether you have products that you sensorize in the field, connectivity, data, and analytics is being used today to drive customer satisfaction and to drive improvements, and a zero downtime, a zero defect vision of using data and analytics is helping manufacturers today drive improvements in their operation. And at the end of the day, look for your weak link. As Isaac also mentioned, it's important to find the right place to start. And it all boils down fundamentally to people, process, technology. I talked a lot about technology and the process behind it, and Isaac talked in a great way and told stories about the people side of it. At the end of the day, we need to understand what is the maturity of the plant in terms of those three areas, and selecting the right area and the benefits you're going to accrue is really as far as the weakest link. So assess your maturity, assess the best area of the operation with the right mix of people, process, and technology, and this will surely, ensure success of your digital transformation pilots and your journey. So with this, I'd like to really thank Isaac Bennett for his time. Thank you, Jean-Yves and R3D for setting up this educational webinar together with us, and we're always open together with the R3D team to have a fireside chat or a discovery session with anybody on the call or anybody who will be listening to this webinar. And we'd be glad to share more knowledge and feedback on how we do things and how we can support you in your digital journey. So with this, I hand it back to Virginia to see if we have any questions.
All right. Thank you very much for this presentation and for everyone still on the line with us. Now we're going to start our Q&A session. If you have not submitted your questions through the chat tab, please do so now so we can read them to our speakers. I do have a question that came up during the webinar, and I believe it is to Mo. So here it goes. It says, what efforts are required from the business side to get results on the POV pilot?
I think that's a good question. So on the proof of value, it's important to have a multidisciplinary team, and it's important to do a proper discovery session, right? And to, again, assess the people, process, and technology side of things. So I think if there is management buy-in from the beginning and the selection of the right mature area to do the efforts, with a proper discovery session, I think it will ensure future success for the proof of value, in addition to having a proper business case to back up the proof of value and to track those metrics as you're moving through the POV. In all honesty, if you're 3 to 6 months in a proof of value and you just keep extending the POV date, trying to buy more time and trying to make it work, there is surely something not right. And in many cases, we would analyze this and we would even recommend pivoting your POV into maybe a different machine, a different plant, a different operation, right? So please don't think that just making the POV time lengthier is going to help make the POV successful. I think you should see the value within a 3-month period of running your POV.
Yeah, and Mo, can I add to that if you don't mind? I
Sure.
think from my experience, I think a lot of times you think that this is going to be a big price tag, and I think you'd be surprised, especially if you have the vision of starting small. We did the financial analysis. We got with our finance team and said, okay, if this particular machine that we're focusing on is downtime, how much does that cost the business? And then we matched that with the cost of the initial pilot project. and we proved that we could get a return on investment within a year. And then as Mo said, once we made that decision, we moved fast, and we had data flowing into the cloud and being analyzed, and the system being set up within a month.
All right, perfect. Thank you. Thank you for that. I do have another question, and I believe this one is for Isaac. Here it goes. What advice do you have to build the ROI and business case around such deployments?
Yeah, I mean, that's kind of along the lines of the last question, I think. I think it's you know, a lot of internal sales, but I think, you know, bringing the concepts to the business first, if they're not aware of the concepts, and then as we discussed, and I'll say it again, focusing on a pilot plant, and then focusing specifically on a very specific pilot problem or pilot issue on a line. And then, as I said, we were able to use finance to build that ROI discussion based on that particular machine. If it had downtime, how much does that cost? And, you know, taking that to the business and saying, hey, we can run this pilot, and if we can prove the value at minimal cost, then we can deploy this across the company. I think once you get those steps down and you're able to put that on paper and get that in front of leadership, I think it's a pretty easy sell.
Okay, perfect. And I think we do have time for one last question. This one would go to Genevieve. So here it goes. It says, is it mandatory to use SAP IP? Can we use any standard interface layer that is standard to my company?
Yeah, I think the answer is yes. I think you don't have to use SAP. I think we cross path with corporation using obviously Oracle, QAP, many other ERPs. So I think as shown in the data layers by Mo, I think to answer your question, there's no need to use SAP. I think the connectors could be with any other database or ERP or MES that you have. I think the connectors, most of them exist. If not, it's not that hard to develop. But at the end of the day, it could be any other platform than SAP, and it would work the same way with the same ROI at the end of the day.
Perfect. All right. So thank you very much to our speakers and attendees. Thank you very much for your time and for your answers. Also, this would be the end of our webinar today, and we will follow up with all attendees for further questions. Please stay tuned to our website and social media channels for this webinar to be reposted, and in that way you can rewatch it and share it as well. And thanks everyone for joining us today. Have a good one and stay safe.
Thank you for the opportunity. Thanks.
Thanks, everyone.
Thank you.